Hello guys! Ngayon naman, pag-usapan natin ang batch enzyme kinetics. Kung saan you have your enzymatic reaction happening in a batch process or a batch reaction. And usually, sa ganyang type of problem, ang hinahanap is yung time or duration ng reaction given kung ilang conversion ng substrate to the product ang meron ka or whatever is specified in the problem. So, let's consider this problem. An enzyme reaction has Km equals 0.001 molar and the initial substrate concentration is 3 times 10 raised to negative 5 molar. After 2 minutes, 5% of the substrate was converted to product. Now, the question is how long does it take to achieve 99% conversion? So, tatandaan lang natin ano ba yung enzyme reaction natin. So, if you're assuming that there is only one active site, so you have your enzyme plus the substrate, okay, whatever the substrate is in this problem, it will form in equilibrium with your enzyme substrate complex. And that complex will soon produce your product. Tapos yung enzyme, mare-recover natin. Okay? So, alam na natin kung ano yung itsura ng rate law for an enzyme reaction. Again, assuming na isa nga lang yung ating active site. You're considering one substrate, one enzyme. Or although there are other models or rate laws that will cater for other types of enzymatic reactions. But if we're going to assume either rapid equilibrium or quasi-steady state, so we know how the rate law looks like, and it's in the form of Michaelis-Menten equation. Now, alam din natin na in order for us to calculate the rate of reaction, so we know na it's equivalent to this form. So you have your rate of reaction equals, diba, product formation, so the rate of the change in product concentration with respect to time. So, ganyan siya. Also, we can write it in terms of the disappearance of the substrate. So, ang nangyayari, magiging negative siya. Equals minus the rate of the disappearance or change in the substrate concentration with respect to time. So, those are the two ways in writing the change in product concentration per unit time or substrate consumption per unit time as an expression for your velocity or reaction rate. Now, we will use this second form here, and we can do that. So let me rewrite it here. Minus ds dt. Di ba siya yung V or rate of reaction? If we're going to assume either the quasi-steady state assumption or the rapid equilibrium assumption, ang mangyayari, it will be equal to the Michaelis-Menten form of the equation, which is maximum velocity times the substrate concentration equals over Km plus the substrate concentration. Kasi diba ito ay equal sa rate, and rate is also equal to minus ds dt. Okay, so what we will do next here is to separate the variables. Okay, so you have a differential equation, and what we're going to do is first separate the variables, knowing that this is a variable separable differential equation. So, magiging minus the concentration of the substrate equals Vm substrate concentration divided by Km plus substrate concentration dt. Okay? And we need to further separate the variables. So, ang mangyayari ay magiging Km plus the substrate concentration divided by Vm times the substrate concentration. So, nilagay ko lang siya sa left-hand side of the equation. And then, tatanda natin na may d or differential substrate concentration pa dito. So basically, I just divided with this whole term here. Okay? Equals, may negative tayo kanina sa left-hand side ng equation. So, gagawin kong negative na lang yung right-hand side ng ating equation. And now, we have separated the variables. So, ang gagawin natin now is basically to integrate each term here. Okay? But probably we should kind of simplify first yung ating equation bago tayo mag-integrate. So, magiging Km over Vm times 1 over the substrate concentration plus 1 over Vm. Okay, I forgot to affix yung differential. So, the concentration of S, okay, plus 1 over Vm, the same, no? Differential concentration S equals minus dt. And then we can integrate. So we'll integrate from initial substrate concentration to a final substrate concentration. Ganon din dito sa term na to. From initial to final substrate concentration. While for the right-hand side of the equation, let's say from time 0 to time t. Okay? Now, we can evaluate the integration or integrand. So, ano mangyayari? You will have Km and Vm these are constant. So, ihiwalay lang natin yan. Km over Vm. Tapos, 1 over S. The integral of that ds is simply ln, right? So ln of s, okay, from initial to final. Sa second term naman natin, 1 over Vm is constant. So magiging integral ni ds is simply s. Okay, or concentration ng s. Evaluated again from initial to final. While the right-hand side of the equation, the integral of dt or negative dt is minus t. Okay, since from 0 to t naman yun, so magiging t lang siya. Now, let's evaluate this further applying the limits. Magiging Km over Vm. Now, ln magiging what? From initial to final. So, S over SO. Okay? Ito naman sa second term natin, 1 over Vm. Magiging from substrate concentration minus the initial substrate concentration equals minus T. Now, if we would like to simply just solve for T, okay, kasi yun usually yung hinahanap. So, T, kumbaga inaalis natin yung negative, equals Km over Vm. I'm just copying the left-hand side of the equation. Ln, but this time, initial muna, divided by the final kasi we applied negative. Okay, so doing the same here, 1 over Vm. So, instead of S minus SO, so baliktad ngayon, magiging SO minus S. Alright, so that is now the equation, okay, for your Michaelis-Menten kinetics in a batch enzymatic reaction. So you wanna write this formula in your index cards. Now, let's answer the question or the problem. No? So, sabi dyan, sa problem, if we just recall here, meron tayong Km value, meron tayong initial substrate concentration, and after 2 minutes, 5% yung conversion. So let me probably write them down here. So again, the Km, or the Michaelis-Menten constant, is Km equals 0.001 molar. Substrate concentration initially, you have 3 times 10 raised to negative 5 molar. Now, sabi sa problem, at t equals 2 minutes, ang conversion ay 5% conversion. Okay? So, the question is, gano'ng katagal kung ang gusto natin is 99% conversion? So, writing it this way, what is t when 99% yung ating conversion? Okay, so how do we answer this? So we'll just apply the formula, right? T, okay, so let's use this one. So T is 2 minutes equals Km, it's known, 0.001, but Vm is unknown. Wala tayo ng Vm. Alright, Ln, okay, you have here a case of 5% conversion. Okay? Initially. So, initially, ito yung ginagawa natin ngayon. Ito yung sinusulat natin. So, this condition here, we're applying that here. Okay? So, kung 5% conversion yan, if you have initially SO, regardless kung given or hindi. In this case, given naman siya, diba? 3 times 10 raised to negative 5. But anyway, if your initial substrate concentration is SO, and then sabi natin 5% yung conversion, so at the end of that, 95% na lang of the initial substrate concentration ang natitira. Okay? Kasi 5% conversion. You might want to substitute SO, no problem, but of course, they will just cancel out. Now, plus 1 over Vm. Okay, unknown pa rin si Vm. And then you have here the difference between the initial and the final. So this time, substitute na natin. So yung initial natin is 3 times 10 raised to negative 5 molar. While your final is 95%. Kasi 5% yung conversion. So, 95% of 3 times 10 raised to negative 5. So, iisa na lang ang unknown dito, which is Vm. So, you will be able to calculate Vm. Okay? So, doing that in your calculators, you will determine that Vm is 2.64 times 10 raised to negative 5 molar per minute. Okay, kasi naka-minute yung time natin, naka-molar yung concentrations natin. Okay, so hindi pa dyan nagtatapos. Again, ang tanong is this. Gaano katagal to achieve 99% conversion? We can now answer that because we know now Km and Vm. Okay, and we know the conversion. So, T is what we're looking for. Equals. So, ano ba yung formula? Nandito tayo. Km over Vm. So, Km is 0.001. Vm is, ito na, yung nakuha natin kanina, 2.64 times 10 minus 5. Ln, okay, of so, meron tayong initial. Right? Pero ang conversion natin ay 99%. So at the end of the process, since 99% yung conversion, anong matitirang amount ni substrate? So magiging 100% minus 99% is 1%, and 1% is 0.01, right? So 0.01 times the initial concentration. Okay? Plus 1 over Vm. So again, meron tayong Vm, 2.64 times 10 raised to negative 5 times. So, initial mo, 3 times 10 raised to negative 5. Ang final mo is 0.01. Okay, so we'll be able to calculate the time required. So the answer is T is equal to 175.6 minutes. In terms of hours, yan ay approximately 3 hours, or to be quite precise, 2.93 hours. So that is the time required for you to achieve 99% conversion.